Now, once I do that, I will have my sigma
H
bond
plus.
broken.
Yeah, you'll have a H plus.
Yeah, that's right. I will have my sigma bond broken, but your
Yeah.
H plus is not moving away. See the consequence. Now, see the difference in the arrow pushing. This arrow does not mean this.
Yes.
You got it? This arrow does not mean this. What you're doing is you are shifting this over here. And now see, you got two bonds on the two hydrogens here, and the double bond. This carbon is now tetravalent, right?
Yeah. So you break one. Yeah.
And this carbon is also tetravalent. And this hydrogen is just hanging around. So effectively, the positive charge which was there on this carbon, the positive charge which was there on this carbon, is getting shifted to this hydrogen. Am I right?
Yeah.
That is spreading of positive charge. Spreading of charge. Okay? Spread the charge.
Yes.
And spreading the charge is known as delocalization.
Oh, what, sir?
Delocalization.
Oh, spreading the charge.
See, localize means what? Localize.
Yeah. A particular position.
Concentrate at one particular locality. Concentrating something on a particular locality is known as localize. Delocalize means spreading it out.
Yeah.
Spreading out is a criteria for stability. This is the criteria for stability. The charge, charge has to be delocalized. This is very important in organic chemistry. Please remember this. Criteria for stability is delocalization. Is that clear?
So this is similar to resonance.
Exactly. Now, what's the difference? What's the difference? Very similar to resonance. But what is the difference? The difference is resonance involved.
Bonds.
Which bond?
Pi bond.
Exactly. Resonance involved pi bonds only. But hyperconjugation involves sigma bonds also. Let me write the word also. But only the CH bonds. Only the CH sigma bonds. No other sigma bonds will be generally involved. Because if you break any other sigma bond, the molecule will be cut into two. Pardon?
Or even CC bonds, right?
CC bond will not. Suppose I break one of the CC bond. What will happen? The molecule will be broken into two pieces. C sigma bond C will not be there. C double bond C will be there. Clear? There will be C double bond C involved, but not C single bond C.
Yes.
Got it? Now see here. Now see here. I have a carbocation. This you must have seen in the book. Right? This is what's the difference between these three?
Yeah.
What's the difference between these three?
tertiary, secondary, and primary.
Yeah. I'm talking about, yeah. What's the meaning of this? What I have written?
The
Yeah.
quaternary carbocation.
Quaternary, it's not quaternary, tertiary carbocation. This is tertiary. This is secondary.
Secondary,
And this is
primary, and
primary
methyl.
and methyl.
Methyl.
What is that? We are talking stability, right?
Methyl.
Yeah. We are comparing the stability of each of these. Am I right?
Yes, sir.
Then, tell me.
Yeah.
Ah, tell me. Looking at what I have written, explain.
Yes.
Look what I have written. You have explained what I have written here. I have just drawn something here. Yes. What does this mean?
Methyl carbocation has more hydrogens. So
Methyl carbocation
has more hydrogens on the same carbon, so it can.
it can look
So it can easily form double.
It can easily form double bond. Is it correct? Have you noticed this sign which I have shown? Have you noticed a sign?
Yeah. Yeah.
What is that? Greater than. Am I right?
Yeah. Methyl is more stable.
But is it correct? Is methyl more stable? Methyl carbocation more stable than ethyl, than isopropyl, than tetrabutyle? Which is the most stablest one?
No.
It is the reverse.
Tertiary.
See that? You didn't notice that, right? You didn't notice.
Yeah.
You shouldn't notice that. That is what I I have purposely done it. This is the one. Now, why is it more stable? Why is tertiary more stable? Tell me. Why is tertiary more stable than secondary, than primary, than methyl? Why? Yeah, hyperconjugation. Am I right? Hello? I think lost the connection.
Hello. Hello.
Can you hear?
Hello.
Can you hear me?
Hello. Hello.
Have you lost the connection? Can you hear? Hello? Hello? Can you hear me? Hello? Can you hear me? Now, so once you have got, so that is electromagnetic effect.
Yes.
Now, that is what is called electromagnetic effect. So these are the four. These are the four electronic effects which affect the chemical reactions. Okay, we'll be using it
Yes.
on and off, on and off, on and off. We'll be using this, right?
Yes.
Okay. Now
Except
let us.
electromagnetic effect.
Pardon?
We don't use. Okay, we use. Yes, sir.
Yeah, as we start writing reaction mechanisms,
Yes, sir.
we'll be using these electronic effects. This understanding is very important.
Yes, sir. Yes.
Okay, now let us look at some practical organic chemistry. Some practical organic chemistry. Now let me go in a very very common way. Suppose I have a mixture of common salt. Common salt is mixed with a little sand. Tell me a method of separating them.
Mm, like mix it with water.
Mix with water.
So and stir it. So the common salt will get dissolved, but sand will, if you leave it undisturbed for a while, then sand will settle down.
Good.
So you can
Continue.
remove that by filtration.
By
You can remove that by filtration.
actually you need not filter it.
Okay.
What do you have to do?
Uh, decantation.
Yeah. Tell me.
Decantation.
Exactly. Very good. Very good. That understanding should be there. What criteria has resulted in this process? What
Difference in
criteria?
solubility.
Ah,
Difference in solubilities of the compounds in water.
is that only? Is that the
And
only
also the
phenomenon
size
which has resulted?
also the size of the particle.
Pardon?
Even the size of the particle, right?
Size of the particle. Suppose instead of sand, I got sawdust, which is also having almost the same size.
Okay.
Will you do this job?
Sawdust, like
Powder, wooden powder.
is it the same as
Sawdust is, wait.
powder? Okay.
A wood, powder of wood.
Okay.
You know these sawmills
Yeah.
where the blocks of wood is being uh, made into
Nice.
pieces, sizes.
Yeah.
Ah,
Sawdust. Oh, difference. Okay, wait. Difference in
difference of,
density.
very good. Difference of,
Density.
exactly. Density. So two phenomena here, density and distribution.
Yeah.
Here you cannot use that. Here what you have to use, what will you use, what technique you will use?
Uh,
Here which technique you will use?
uh, the same, I guess.
Decantation? A big no.
Like even that is dust, right?
Huh?
Even that is dust, right?
That is dust. Exactly. It is insoluble. I agreed. but you cannot use decantation. So what is decantation? What is decantation?
Just pouring the water off.
Exactly.
Like,
Yeah,
yeah.
pouring the water off. For that purpose, it should be very dense. Remember, if you put sawdust, it will float on water. Sawdust
Can
will
it
float. Much of the sawdust will float on water.
can it pass through filter paper?
Exactly. That technique is called
Filtration.
filtration. This is important. Decantation and filtration, where you have to use, this is how the questions come. See here. That's what I told you to go deeper into it. This level of thinking, this is just minimum level. Got it?
Yes, sir.
Now tell me logically, think very carefully. Now, heating water and removing water is very energy consuming. Okay?
Yes, sir.
High energy consuming. Right?
Yeah.
Right. Keep this in your mind always. Therefore, nobody will prefer to prepare a water solution
Okay.
and get your product out. Now, before that, one sec. We forgot one thing here. We have to, yeah, that when just now come here. We have decanted.
Yes,
What
sir.
I got is in the beaker bottom, I have got my sand. In the second beaker, I got the water solution. Am I right?
Yes, sir.
Which contain common salt.
Yeah.
What should I do with this?
Evaporate.
Evaporate. Evaporate. Am I right?
Yes, sir.
When you evaporate, the whole liquid will go off.
Yeah.
And yes. Now my question. Can you tell me, you know there is a raw salt?
Yeah. Raw salt.
And powdered salt. Have you seen that?
Raw salt, you mean rock salt?
Not rock, no, raw salt, raw common salt, which you directly take from the fields.
Okay.
This is the second one is sprinkled salt.
Okay, yeah.
They say sprinkled salt or something. Okay?
Yes, sir.
Can you think how they prepare this and convert this into this? How is raw salt made?
How is it made?
Huh?
Oh, what, sir?
See, raw salts, if you take a packet of raw salts,
Yeah, yeah.
you get big crystals, right? Lumps like.
Yeah, yeah, yeah. Yeah.
Lumps like, right?
Yeah. Yeah.
How are they made? Have you thought of it? The other one will be this, sorry, right? Powder, almost
Yeah.
beautiful, free-flowing powder if it is dry.
Yeah.
Am I right?
Yeah.
How is this converted into this?
They apply pressure, I guess.
Simple powdering, right? Simple
Okay.
powdering. Am I right?
I don't know, sir.
No, it is not. The powdering will not give you the exact uniform crystals.
Okay.
Now tell me, which is better crystal? This one or this one?
Crystal.
Yeah. These are see lumps like they are actually crystals
Yeah,
of
but
different shape,
impurities.
right?
Yeah.
Okay. How are they made? Any idea? This
They're,
raw
they're
form.
available in the sea.
Eh?
They're in the sea, right?
Exactly. What do they do?
They evaporate it.
How
The
do they
water.
evaporate?
Just keep it under the sun.
Exactly. Okay, to the very in the shore, they have low lying area. Allow the water to flow and
Yeah.
keep it like this, exposed to air, sunlight.
Yeah, yeah.
Slowly, very slowly, I understand that. Slowly the water gets evaporated off.
Yeah. Yes, sir.
No energy required.
Yeah.
And it forms very good crystals in fact. Very good crystals you get. Right? And the water
Yes,
is
sir.
almost completely getting drained off. Since the
Yeah.
process is very slow, you get big lumps, but non-uniform in size. And it is
Yes.
completely evaporated off. Right?
Yeah. Yes, sir.
Suppose you are doing this in a beaker. Suppose you are doing this in a beaker, you dissolve and then start heating it. Okay?
Yes, sir.
Now you keep on heating it till the water is 1/10. Till the water
Yeah.
has become 1/10 of original. You can see
Yeah.
now a small crystal will appear, a small piece will appear.
Yeah.
Now you allow to cool, this crystal will start growing.
Yeah.
Okay? And what you can do is you can just, after some time, you can just take a filter paper, a funnel, right?
Yes, sir.
And filter this. Okay?
Yes, sir.
Right? Now tell me, here you have used evaporation. Am I right?
Yeah.
Here you have used evaporation. What technique you have used here?
Uh,
What does sunlight do?
evaporates the.
Evaporates. What we have done here also evaporation. But what's the difference here?
Heat was provided.
Pardon?
The heat was provided, right?
Exactly. The same heat is also provided here. Only we don't know it.
Yeah.
That way both are the same. What's the
It is
difference?
faster.
Which one?
The right. Yeah.
No other difference?
Uh,
No
more
other difference?
pure crop.
Louder.
Uh,
Ah, I think
it's
you
more
used
easy.
I think you used the right word. I missed it.
Uh, it's easier to.
What's the difference? What is the difference?
It's pure.
Ah, that's right. Which is pure? This one or this one?
No, the heating.
The second process.
Yeah.
This is the second one. This is the first one. This also is the first one. Why is it more pure? Why is this more pure?
Because like you provide the sufficient heat.
Okay.
So
Here also you are providing sufficient heat. Whatever amount of heat you are putting it. Why this is more pure? Now look here. There is a change in there is a difference in the process procedure here and here. What is the difference? In 1 and 2, there is a difference in the process. What is that?
temperature is so high in the second one.
Temperature, no, temperature is just the same. Then see, now suppose I keep a beaker exposed to air, right?
Yeah.
Exposed to air, it may take 1 hour or 10 hours to get rid of this water.
Yeah, this takes very less time.
That's okay. That's okay. But effectively, the energy required by both of them is just the same.
Okay, yeah.
Because if you have the same amount of water, then the energy requirement will be the same. Only thing is rate of removal of water will be different. That will not make any difference. But what is the difference in process here? Look at the process we have done here and the process done here. There's a difference in the process. And that makes the product more pure. What is that?
It's done in a smaller volume.
Pardon? And then?
Filtered.
Filtered.
Yeah.
What's the consequence?
So impurities like
where is impurity?
Impurities
yeah, impurity is here.
Yeah.
Impurity has come along with the liquid down. And your crystal is pure. That process is not here.
Yes, sir.
You got it?
Yeah.
And this process is known as not as evaporation. This is known as crystallization. Is it clear?
Yes, sir.
So you have to distinguish between these two. Is the concept clear to you?
Yes, sir. Yes, sir.
Okay, good. Suppose I mix ethanol, water, and acetic acid. How will I separate these three?
Use that funnel, right? The differentiating funnels.
Differentiating funnel?
I don't remember the name.
Yeah. You take your textbook.
Textbook.
Yeah, you studied from your textbook, right?
Yeah.
Take the book. Open the book. You have an open.
Differentiating. I don't.
Pardon?
Differential extraction.
Differential extraction?
Yeah.
What is that?
Removing an organic solvent from an aqueous solution.
Yes. Yeah, that's right.
Ethanol from water.
Ah.
You first do that.
Ethanol from water?
Yeah.
Okay. What will you do? Okay, let's see. What will you do?
Ethanol is separated, right? From the mixture of water and Ethanol will get separated from water and acetic acid.
How? By
Difference in
extraction?
density.
By extraction?
Yeah.
With what? Extract with what?
Uh,
Now look carefully. When an organic compound is present in an aqueous medium, when an
yes,
organic
sir.
compound is present in an aqueous medium, it is separated by shaking with an organic
Shaking.
solvent in which it is
Yeah.
more soluble. Am I right?
Yeah. That,
In which
yeah.
it is more soluble,
Yeah.
right? The
Yes, sir.
organic solvent and the aqueous solution will be immiscible with each other.
Yeah.
Organic solvent and aqueous solution should be immiscible with each other. Good.
Yes.
So that they form two distinct layers which can be separated by a separating funnel.
Yes, sir.
Okay, that is very clearly given over here, right? But look here,
Yes, sir.
here is ethanol, here is water, here is acetic acid. All the three are totally miscible. Totally miscible. Got it?
Yes, sir.
Okay, miscible with what? With water. You know, what is a mixture? We use acetic acid in the kitchen. What's the name?
Vinegar.
Vinegar. Oh my God, my power is going on. My power is gone. Another 5 minutes. Okay, we'll be compelled to stop. No problem. Now, ethanol mixture with water, we call it as
Yes, sir.
liquor.
Okay.
Okay,
Yes, sir.
right? Now,
Yeah.
you know how liquor is made, manufactured?
Fermentation, I guess.
Fermentation. By fermentation, what is the percentage you get?
I don't remember that.
5%. But
Okay.
what is uh, the brandy contain how much? 55%.
Okay.
Whiskey contains?
The least is beer.
Yeah, exactly. This contains 45%.
Yes, sir.
Beer
Okay.
contains 8%.
Yes, sir.
Wine contains 4%.
Okay.
So what you are getting by fermentation is wine only. Then how do they manufacture brandy? What is the process?
I don't know.
Distillation. Distillation. Got it?
Normal distillation.
Ah, distillation. Whatever. Let us see what type of distillation we'll see.
Yes, sir.
Right? Distillation is a
Yeah.
process. No, see, this is the type of learning you should make. Critical learning. You have studied
Yes.
all this. Good. But where you have to apply this, that we have to judge. Right?
Yes, sir.
Now, we have miscible liquids. Two miscible liquids.
Yes, sir.
Miscible liquids, there is no other way for separation. They can be distilled. Provided, what is the condition? They can be
Difference in
distilled to separate. Provided.
boiling points.
Yeah, they have a considerable difference in boiling point.
I guess 25K. I don't know.
Ah, 25?
Degrees or Kelvin. I don't remember.
Difference of 25, right? Right?
Yeah.
Okay, good. I appreciate. No problem. Now here is 69. Here is 100. Here is 116. Right?
Yeah,
You start
fraction.
voiding it. Oh, my power is gone. Okay, we'll continue tomorrow.
Yes, sir. Yes, sir.
Okay, thank you. Tomorrow, 3 o'clock.
Yeah, yeah, yeah.